Welcome to this tutorial on NumPy. In this video we will explore the basics of NumPy, including how to create arrays, manipulate them and perform essential operations. NumPy, or short for Numerical Python, is a crucial library for numerical computing in Python. It provides support for multidimensional arrays and a wide range of mathematical functions, making it an essential tool for data analysis, machine learning, and scientific research. Now let's discuss some advantages of using NumPy. It offers efficient array operations, outperforming the standard Python lists for large datasets. It also supports broadcasting, simplifying element-wise operations on arrays with different shapes. Also, the library provides a rich collection of mathematical functions for various operations, and its seamless integration with other scientific Python libraries will streamline your workflow. Okay, now we can get started with the tutorial on NumPy. And the first thing we have to discuss are NumPy arrays. It's the core data structure in NumPy, and you will use them almost exclusively when you work with NumPy. They are very similar to the built-in Python lists, but have some special operations and some speedups which make them much more useful for large data science projects. Here we can see a short example of how we can create some NumPy arrays. So at first we have to import NumPy, and then we can create a normal list. Here just a Python list 1 to 5. And if we want to create a NumPy array, we can simply call np.array and the list as an argument. And if we take a look at this array, we can see it prints it like a normal array. We can also do this for multidimensional arrays, like here with a 2D array. It works the same, and we can see it prints just fine. NumPy also provides some functions to create some specific arrays. So here, for example, np.zeros, and then we pass in the shape of the array we want to create, and then we can see it creates an array 2 by 2 with only zeros. The same works with np1s, then we only have ones here, and we can also say np.full, then the shape and the value we want to put in it, and then we get this array. And yeah, we can also create the identity matrix with np.I and the dimension of the identity matrix. So here we have a 3 by 3 matrix. And yeah, we can also create random arrays. So we call np_random.random and say we want a 2 by 2 array, and then it gets filled with random values between 0 and 1. NumPy arrays differ from normal Python lists because they only can store a specific data type. So in Python lists you can put integer, float and strings at the same time and you won't have a problem. But with NumPy you can only put one specific data type in it. And if you just create this NumPy array, we can let NumPy choose the data type automatically. And if we do this here, we can see we create a NumPy array with 1 and 2. And if we take a look at the type of the NumPy array, we can see it's an integer array. And we can also create a NumPy array with float values. And NumPy again chooses the data type automatically. We can see it's a float array. But we can also tell NumPy what kind of data we have and force it to use that data type. And we do this here. And then even if we put floats in here, we only have integers in here. And if we set a data type for the array, we can also only put these types of data into the array. Okay, now we get to array indexing and slicing. And array indexing is pretty easy. It works just the same as with normal lists. So here we again have a numpy array. And if we want to access an element, we can use these brackets. And with the index of the element we want to retrieve, we get here the first element. And if we print it, it's 1. And if we take a look, that's correct. Now we get to a specific feature of NumPy. That's the so-called array slicing. And we have some more possibilities to retrieve data from these NumPy arrays. So if we take a look at this example, here we create a 3x3 matrix. And if we want to retrieve a specific element, we can open these square brackets, say we want to access the element in the first row, and then we can write a comma, and then say we want the element in the second column. So we get the element at the first row, second column, and we only have to use one square brackets because we can use this comma separated method of indexing. Then we have some advanced features. We can use the slicing, and let's say we want to get row 0 and 1 with all columns. So we can use this method. So at first we have to select the rows, and we can do this. At first we have to define the start value, then a colon, and then the stop value, but the stop value is excluded. And then we want to select the columns we want to print. So again, start value, colon, stop value. And this gives us row 0 and 1 and all columns. And here we have all rows, so from 0 to 3, and only column 1. And if we take a look, here we can see we have the rows, and here we select this column. If we don't want to specify the start and stop value, we can also only write a colon, and then we get the entire row or entire column, and this can be seen here. Now we get to integer indexing. Integer indexing allows us to use another array as the index for retrieving data from a NumPy array. So here we have an indices array with 1 and 3. So we want to retrieve the items at position 1 and 3. And here we simply use the square brackets and pass in this array with indices. And if we take a look, here we have the element at position 1 and 3. This also works with multidimensional arrays. We just have to create 2 indices arrays, and then we select rows 0 and 2 here, columns 1 and 2, and if we use this as an indice, we can see we get 0, 1, the element, so the 2, and 2, 2, so the 9. And we are also not limited to one type of indexing. We can mix integer indexing with normal indexing. So here we select the rows with this indice array and all columns. And here we select all columns, and the rows with this method. And here we can take a look at the results. Another important property of NumPy arrays is the shape, and with the shape we can get the number of rows and columns, or just how many elements are in the array depending on the dimensionality of the array. So here we have a one-dimensional array, and if we call shape, we get the output. So shape of the array is 5, and here we can see we have 5 values in this array. For multidimensional arrays, it's pretty similar. Here we create a multidimensional array, and then this shape is a tuple with 2 values, so the number of rows and number of columns. And here we can see we have 2 rows with 3 columns. And yeah, this works also for higher dimensional arrays. The last thing I want to talk about is Boolean array indexing. So here we create a new array, and then we want to define some condition which values we want to retrieve. And our condition is that the value should be larger than 2. And we can create this Boolean array with this condition, and if we take a look, we can see these 2 values are smaller, and therefore we have false here, but every other value is larger than 2, so we get a true. And now we can use this Boolean array to index the previous array. And if we do this, we get only the values which are larger than 2. And we can also do this in one single statement. So we can put a larger 2 directly into this indexing brackets.